This Late Night Linux Family podcast is made possible by our patrons. Go to latenightlinux.com/support for details of how you can join them. Support us on Patreon for access to ad-free episodes and early releases. That's latenightlinux.com/support. 2.5 Admins, episode 273. I'm Joe.
I'm Jim.
And I'm Allan.
And here we are again. And before we get started, your customary Clara article plug, Allan, is building enterprise-grade storage on Proxmox with ZFS.
Yeah, so if you're considering using Proxmox, and as I know a lot of people are now, then we talk about some of the advantages of doing it with ZFS over Ceph, which is the other common thing for Proxmox, and just how you can get the most out of ZFS and Proxmox together.
And you've got another webinar to promote.
Yes, so December 10th, Jim and I will be together to do the 12 days of ZFS, an early kind of Christmas theme, talking about tips, tricks, and treats about ZFS, everything from managing your free space and expanding ZFS snapshots and maybe a little bit more about bookmarks and all that, plus learning how to tell which data set is the one making the pool busy and lots of other interesting breadcrumbs for you.
Right, well, links to both of those in the show notes. Allan, you recently went to the OpenZFS Summit and saw some quite interesting stuff there.
Yeah, this was the second year where we've had a combined user and developer summit, and it's been really valuable to have that much more input from users as well. The first main talk was from one of the sysadmins at MIT's AI lab. Of course, you know, MIT's AI lab's been around since before the 70s, so it's not really the same kind of hype as everybody else's AI lab. But they were talking about some really interesting things with JBODs. So, you know, over time, they've had various different storage servers to run their NFS and hold all their AI research and so on. And so they have a kind of eclectic mix of different JBODs and have found that, you know, even if they buy 4 identical JBODs, they never turn out to be actually exactly the same. Everything from, you know, which slot number is the bottom left corner slot, or even how are the slots named and numbered when you look at them up over the enclosure protocol? Is it, you know, slot space 01 and slot space 02, or slot 01 and 02, or do they not prefix the zeros? Do they pad it out with spaces or not, so that, you know, slot 20 doesn't come before slot 3 and all the things like that. But even worse ones, they had one where the drives are broken down into 3 separate SAS backplanes, and it was left, middle, and right. And so which drive was on which controller was completely random. Like, they would just be like, oh, drives 7, 8, 17, and 18 are on this controller. And, you know, they're all just discontiguous numbers and really all kinds of different strange things. You know, that devolved into everybody sharing their horror stories about how evil their JBODs are, including Alec talked about at a previous company where they had done a bunch of analysis to try to find which port in their JBOD had the lowest latency to put their slog SSD on that one. And out of their 60 identical JBODs, it wasn't in the same slot on almost any of them, even though I'm pretty sure the cables inside are pre-cut to the different lengths. And so it shouldn't be that much variance, but apparently it really depends who put it together at the factory that day, which slot was the fast one to put the slog on. I had never actually considered the variance to be so big as to be a concern for the slog, but now I have a whole new thing to start looking at.
Well, how big was the variance, though?
I don't know if it was that big, but apparently enough that it was worth time to put the slog on the one with the lower latency.
Was it?
They claim it was. I don't have numbers.
Because that smells like classic yak shaving from where I'm sitting.
A little bit.
And Paul from Clara, your company, talked about AnyRaid then.
Yeah, so this was a feature that the people at HexOS contracted Clara to build to allow mixed size drives to be mixed together into a more flexible VDEV.
Yeah, Jim's favorite feature.
But, you know, when we were designing this, we didn't really consider any potential enterprise use cases because that was not something we saw there being any appetite for. Because, you know, the way ZFS is designed, you know, we assume that enterprises can just buy a bunch of drives of all the same size and it's no problem. And that's true. They don't generally have the need for that. But based on other things we learned at the conference, it turns out maybe there is some appetite for more flexibility in ZFS and being able to change things after you create a pool.
Tell us a little bit more about how AnyRaid is supposed to work. How does it compare to, say, Synology's hybrid RAID or UnRAID?
People have talked about something like Synology's hybrid RAID before. It was like, well, I just took all my different drives and partitioned them into even-sized things and started making different VDEVs out of them. The complexity there is really making sure you don't ever screw up and end up with, two chunks of any one stripe being on the same disk. I think get really complicated when you're dealing with a whole bunch of partitions that are maybe just letters in your /dev. So AnyRaid will slice up the disks into what we call tiles. They're much smaller than Synology. They're like 16 gigabytes or 32 gigabytes, depending on the size of the drive. Usually at most like 1/64th of the drive. And then it can combine them into stripes. So the version that's out in a pull request today is only mirroring, but the RAID-Z version is a working prototype at this point. And so if you have 7 different size drives that you're combining together and you create this with a stripe width of 5, then it will pick, one tile each from 5 different drives, and that'll be the first RAID-Z stripe. And then when it makes the second one, it will pick different disks and in particular try to take the disk that's got the most free space so that it'll get all the usable space out of the combination of drives. But the fact that the stripe width is not as wide as the VDEV also means it's possible to contract the VDEV. So if you have a 7-wide RAID-Z AnyRaid and the stripe width is 5, then you can actually remove one of the devices and just make it only 6-wide. And it'll just shuffle tiles around from the full drive to the drives that aren't as full until, as long as you have enough free space, that'll work. And then you can add another drive later and grow it and have a lot of flexibility. And one of the features we're working on is a rebalance mode. So if your pool is almost completely full and then you add the big drive, AnyRaid can't actually make that much usable space because it has to make sure that each part of a stripe is on a different drive so that if you lose a drive, we don't take out 2 of pieces of a single RAID-Z1. And so the rebalance mode allows it to actually move tiles from the full drives to the empty drives to rebalance things so that we can make sure that it's going to work. But the difference over the Synology thing is it knows which chunks are part of which stripes and make sure that we don't ever end up putting 2 chunks of a stripe on the same drive where a failure would actually lose data. And so it's kind of a smarter automated version of the Synology hybrid RAID.
Well, Synology's is already automated and already makes sure of those things for you. It sounds like the difference really is just whether it's all done in file system code or whether it's done like a sysadmin who can't patch the actual code and just has to work with the tools he's been given.
There are a few differences, especially just the way ZFS has visibility on it. But yes, I suppose it's about the same. One of the other interesting things that came up from the talk is ways we could look at improving the performance of AnyRaid. By default, that first stripe is going to combine just 5 of your 7 drives, and the other drives aren't necessarily used. And they wouldn't get used until we went to the next tile. And maybe there actually should be some load balancing to spread it across a couple of different sets of tiles in order to get all the drives busy at once. But AnyRaid also specifically tries to avoid using up tiles until it has to, so that we preserve that flexibility to avoid having to reflow until the pool is actually quite full.
It sounds like once you pull RAID-Z functionality into AnyRaid, you'll essentially have produced the thing that most of the people who ask me about DRAID actually wanted. Because I field a lot of questions from people who are very interested in DRAID and have like 20 or fewer drives, and I have to tell them, I'm sorry, no, this really isn't for you. You can play with it if you want, but this was not designed for your use case. It was designed for I think it was actually designed for 90 and up. I tell people if you don't have 60 drives, you really shouldn't even be thinking about DRAID.
Yeah, well, the biggest trade-off with DRAID is the fact that every write is always a full stripe write. So if you have a 1 kilobyte file and a 12-wide DRAID, you're using a 4K sector on all 12 drives to store that 1 kilobyte file. Most of it's actually padding, but...
I've wished for a long time, though, that I could set stripe width independent of the total number of drives in the pool. Because, maybe I want to use 12 drives, but, I understand that, I'm doing RAID Z2 and therefore I would prefer to have, 6-wide stripes. Obviously, I just picked something that you can cut in half. So, of course, I could have just made 2 6-wide VDEVs. But in general, I think that there are a lot of circumstances where you'd be better off with an ideal stripe width, even if it's on a non-ideal total number of drives in the pool.
Yes, although ZFS is pretty smart about that, but yeah, exactly. And really, this flexibility came in during the next talk when Seagate talked about drives where individual components can fail and you can regenerate the drive to just be a bit smaller. So, if you have a 20 terabyte drive, that'll have 10 platters and 20 heads. If one head fails, you now have a 19 terabyte drive instead of a 20 terabyte drive. But today you have to replace the whole hard drive. Or maybe you can get the drive to reformat itself and show up as a 19 terabyte drive. But in that case, you're still having to resilver the whole drive. With the new feature, you'd actually be able to just get notified from the drive that, this range of blocks is not reachable anymore. Resilver them somewhere else and, the rest of this drive still works.
Is that specific to ZFS then, or is that in the firmware of the drive?
So that feature will be in the firmware of the drive, and it's a standard that's going to include Western Digital, Toshiba, and Seagate. Right now, ZFS can't work with that, right? If you bring the drive back and it's smaller, RAID Z can't handle that, right? It'll say this drive isn't valid to be part of this VDEV because it's 19 terabytes and every other drive is 20 terabytes. But if you have AnyRaid, you could take the 1 terabyte of missing stuff and move it to a spare or just other places on the other drives that have not been allocated yet. And your pool will be a terabyte smaller, but you won't have to replace that drive. For big hyperscalers, that means not sending someone to a data center to physically switch a drive, which might actually be more interesting to them than just the loss of a little bit of space.
So you're telling me that this hacky feature that we laughed at actually could have some real world use for big companies?
Yeah, for giant enterprise. And, we've seen interest from other vendors who are like, people want warranties on their servers for more than 5 years now, but can we make something flexible enough where their pool's not going to be terrible after 5 years, or where, the hard drives are starting to fail, but we can still get life out of them without having to, actually ship a replacement drive for a drive that's more than 5 years old and they don't make that drive anymore.
I promise you, this is not just a feature that's interesting at enterprise scale. As a matter of fact, I would argue that enterprise is probably less interested in this feature. They just have more money to pay for it being developed. But home data hoarders absolutely would love to go on using 19 terabytes of a 20 terabyte drive that had, a failure in one area of the drive. Like one platter goes bad, but the rest work.
I absolutely would, yeah.
I'm still a little bit in the camp of, once you start failing, you get out of my house. But they cited a Google study that showed that, drives that had this happen once did seem to go on and be fine after that. And Seagate also talked about this bit is Seagate specific, the field accessibility and reliability metrics, or FARM data, which I know we've talked about a tiny bit on this show before as a way for a Seagate drive to tell you if the smart's been tampered with.
If only it said tracking instead of metrics.
But it turns out that feature can actually give you details about every head and its reliability. And you should check out the presentation if you're interested, but there was a huge amount of detail that you can get from the hard drive that goes way beyond anything you've ever thought you would get from the not so smart data, especially on SAS drives where you get even less than you get on a SATA drive. But the farm data can give you a lot of really interesting stuff, including information about the reliability of individual heads to possibly predict when this is going to happen and maybe be able to move the data before the element goes offline.
Yeah, that seems like a really good idea. Shuffle that data around before you absolutely need to.
It does, but I'm going to be as cynical as I always am and say that the proof's going to be in the pudding. Because this is basically an extension of the same idea that we've had for at least a couple of decades now, the bad sector remap table, which in theory, if you develop a bad sector on a platter, the drive will notice that, will mark it as bad, will store what would have gone in that sector into a different sector that is not bad from a reserved area on the platter, and everything will just keep on working fine. Now, in theory, and usually in practice, that's the way that works, but I know I have had drives before that I have discovered a bad sector on that anytime that sector was accessed, read or write, it would lock up the entire system. And in order to work around that without having to replace the drive, because at the time I was rather working poor, I would just make a text file containing that one sector and call it bad sector don't touch, and then continue to use the drive for another 4 or 5 years. So the question is just going to be, does this work as advertised? Because as advertised, this is a great idea. But will it be implemented the way that it's described?
Well, in particular, this is a bit different than bad sectors in that this is an element, like a physical piece of the drive, in this case, a head, failing. And so, unless your drive has a spare terabyte in it of reserved sectors, it's not going to be able to just rewrite the data.
Well, it's different in the sense that it's not remapping it and just letting you put it elsewhere on the drive because there's no room for it. But the part that I'm pointing out that doesn't always work as advertised is literally just detecting it and tagging it out to begin with.
Right. And some of this does seem like you would use the farm data and have to do the analysis kind of yourself to decide that this head is not worth trying to use anymore versus a clear signal is, head number 7 is dead, rebuild your data. A couple other interesting things they talked about was their roadmap for hard drive sizes. They've basically proven they can make 50 terabyte drives and they will ship in 2028. And based on that, they've got lab stuff, meaning that they're getting close to having the 100 terabyte drives, and those would ship in like 2032.
That still seems quite a way off, though, to me.
Does it? To me, it seems fine. Drives are already more than large enough for what I need in any of the contexts that I need drives. If I could do the same thing with a quarter of the drives, using 80 terabyte or 100 terabyte instead of 20 or 25, I mean, that's fine, but I'm not like dying for that.
Well, the one trade-off there is if you have fewer drives, you get fewer IOPS.
That depends on how that's been implemented.
That's the one thing Seagate hinted at is, one of the other things on their roadmap is NVMe connected hard drives, mostly because it would be cheaper for Seagate if they didn't have to make SATA, SAS, and NVMe drives and just made all NVMe drives. And maybe also they could put HBA vendors out of business with that. But it also unlocks some capabilities. When we looked at 5 years ago or so, the dual actuator drives, where we're going to suddenly get twice as many IOPS out of a hard drive, finally. The problem was they could only be SAS, and they used dual port and basically showed up as 2 half-size hard drives. So your 20 terabyte drive would show up as 2 10 terabyte drives. But it meant, could never be used by a home labber because it needed SAS, and it was, a lot more complicated. But if it was done with NVMe, you could use namespaces where you wouldn't be limited to just dual porting. So suddenly the possibility of a quad actuator drive also becomes a possibility. And then you could actually get 1,000 IOPS out of a hard drive if you have the right workload and configure it in your file system right, and a lot of provisos. But suddenly a 100 terabyte drive is less scary if it actually has more than 250 IOPS.
And even less scary than that, if it's actually got more than 250 IOPS, and you have a pretty good idea that you might be able to only lose 10 terabytes off that drive and keep using the other 90. I think at this point, once we have all those things, that's when the question really starts to get interesting, of like, forget the gum sticks and the 2.5s and even the 3.5 inch form factor that hard drives are in now, maybe 5 1/4 or even larger starts getting interesting at the point where you can say, okay, but it's technically not one drive. It is now effectively an array in a box. We've got, maybe we can pack 8 different sets of, mechanical heads and platters into one chassis with one power and data connector and just run them all as like a RAID array in a box. At that point, I think it gets a lot more interesting looking at the larger stuff because we really are getting into a point where what it's actually about is data and power and heat dissipation density.
Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. If you want to join those people, you can go to 2.5admins.com/support. And remember that for various amounts on Patreon, you can get an advert-free RSS feed of either just this show or all the shows in the Late Night Linux family. And if you want to send in your questions for Jim and Allan or your feedback, you can email show@2.5admins.com. Max writes, I have a security-sensitive job where we're still allowed to RDP to the company systems from our own machines, as long as we install the relevant VPN clients and whatnot. Would you recommend using a mini PC in this case, or just a VM with GPU pass-through from my much stronger main machine? Would a mini PC just for work make sense with regards to security and reliability, or am I being overly cautious? And do you have any advice on specific vendors?
As far as security goes, I don't think there's a whole lot of difference here. The biggest thing that you get security-wise from having a dedicated PC for nothing but this case is you've got the maximum amount of isolation from, the the screwing around on the internet you do when you're not working, which is going to be usually your biggest vector for security problems, is going to be some bleed over for something you were doing on the internet taking effect on something you're doing for work. If you have a computer that you do nothing but RDP to work with, well, that's going to be the most secure way you can do that. Now, a VM with GPU pass-through is also going to provide some isolation because it's a separate VM. It's not what you're normally browsing with. But you are probably browsing for fun on the main machine that hosts that VM, so the most dangerous thing you're doing is on the wrong side of the isolation barrier. So yeah, for security, I would definitely recommend the dedicated PC. With that said, I wouldn't yell at you for just RDPing from your main computer if your work allows it. So this is really a question of how do you want to do more than what work allows? And in that case, I think the mini PC is the better answer.
Yeah, there can be extended things to this as well. Depending on where you live and the rules and so on, there can be tax write-offs for using a separate machine specifically for work. Even just mentally separating your work computer from your home computer can make working from home feel a lot less terrible. You know, I'm lucky enough to be able to change rooms between being at home and being at work, but even just changing machines, or even if it is just whether you're RDP'd into the work machine or not, having any difference between this is work and this is home can be really helpful mentally and for burnout reasons and so on. But also it can just help you remember, hey, this is the work machine. I don't do that on this machine. Even if it's just browsing certain websites or checking your banking or whatever. Oftentimes a machine that's for work, maybe you have to be on a certain VPN, but maybe you also need to have certain endpoint protection software installed and so on. And if they're monitoring everything, or like if all the traffic is going through the VPN and they're going to be able to see what you're doing, you maybe don't want to be doing certain parts of your day-to-day life on that machine. And so having it be separate gives you not just the physical change, but it's also about the way you think about it. It being a separate machine instead of just a virtual machine that lives inside your machine can help you make that kind of mode switch.
And if you want to take it a step further, odds are really good that you're probably going to want to do some browsing locally while you're working with RDP over VPN. You're probably not going to want to do every single thing that you do on the internet on the work computer that you're RDP'd into. If that is the case, given that you are in a security conscious frame of mind, which I applaud, I think you should consider having two VMs, one for your RDP and one for the browsing. Do all that stuff on your mini PC, and now your VM isolation barrier becomes a lot more meaningful because now your work is in a different VM from your browsing, and the host, which can control both VMs, isn't touching the internet and doing yucky stuff at all. So security-wise, that's going to put you in an even better position. Moving on from there, the question about vendors, we should probably talk form factors as well as vendors. Joe might, of course, mention that the Wise thin clients you can pick up for next to nothing on eBay are great for this purpose. And that's probably about the cheapest thing that you can get for this. On the other hand, if you want to buy a new dedicated mini PC, the brands that I've recommended in the past are Chotem, which usually is what I recommend for, industrial type stuff. You're looking to just throw a box in a corner of a warehouse somewhere and you want it to be rugged. You don't necessarily want it to be pretty. It doesn't matter too much what it's like to work on inside. It's just a reliable, cheap, rugged, ugly box. Chotem is great for that. If you want something a little nicer, I recommend Minis Forum. Minis Forum makes nothing but miniaturized PCs, the little form factor you can hold in the palm of your hand or bolt to the back of a monitor. They're not all that expensive. They usually come with Windows licenses, and they're very, very easy to work on. They have very nice features like toolless release for the latch and, actual bays to put drives in, sometimes multiple SSDs, even a little palm top form factor. Finally, you might want to consider picking up, sometimes people call them 1 liter, small form factor PCs, the little Dell Optiplexes that you see in every bank and office that you go into. Those can also frequently be picked up either new or off corporate lease very, very cheaply. They don't take up a whole lot of room, but they get the job done.
Or you can do what I did and get yourself a free Lenovo all-in-one with a smashed screen and then just rip the guts out of it, get your grinder on the back plate for it, screw it all together, and you've got yourself a free little mini PC.
Of course, you also have to budget in the cost for emailing Jim to figure out how to actually get the thing to boot because it's not showing the external display.
Only with Windows. It's fine with Linux.
Max is also asking about the performance implications of just doing a VM with GPU pass-through from his main machine or a separate mini PC. Obviously, his main machine is going to be bigger and beefier than anything he's going to buy for a dedicated mini PC, but ultimately, I don't think the performance is really going to matter either way. Any machine that you can realistically purchase that was made in the last 5 or 6 years is going to be more than beefy enough to act as an RDP client. Even inside a virtual machine, it'll be fine. The better question is just, do you want, any of the performance implications of hosting this VM on your beefy main rig that you probably want to play games and stuff on, where you would notice a difference in performance, not in the RDP application, but in the other stuff that you want to do.
Yeah, or like where you would miss the 8 gigs of RAM you might give to the VM. I think the biggest thing if you're buying a mini PC, especially even a cheaper one, is don't skimp on the NVMe drive that goes in it, because that's probably the thing that's going to make the biggest performance difference for your desktop productivity apps, is making sure your disk isn't trash.
Right, well, we better get out of here then. Remember, show@2.5admins.com if you want to send any questions or your feedback. You can find me at joelrest.com/mastodon.
You can find me at mercenarysysadmin.com.
And I'm at Allan Jude.
We'll see you next week.